Hi, my name is Dhruv and I'm a tutor at Tutor Here. And this video is to give you an intuitive sense about what a frame of reference means. So let's get started. A frame of reference is any point from which you can measure quantities. Now, which quantities would you want to measure? Quantities like velocity, acceleration, displacement. All these quantities will change if you change your frame of reference. So let's go through an example to better understand how important this is. Okay, so here is a boy who is standing on a train, or let's say he's traveling on a train, and this train is moving from left to right. All right, fair enough. There's another boy who is on the ground. Okay, he is on the ground, and when he looks at this train, from his frame of reference, the train looks like it's moving from left to right, all right, with some velocity v, let's say. So from the frame of reference of this boy, if he measures the velocity of the train or he looks at the train, it's moving from left to right. Now, let's change our frame of reference. If, let's say, you're on the train along with the other boys on the train, if you both are on the train and you see this kid who is on the ground stationary. Now, from your frame of reference, if you look at this kid would look like he's moving from right to left, all right? So when you change your frame of reference, things appear differently. Something from one frame of reference might be something completely opposite from the other frame of reference, okay? Let's go through a few more examples to build our intuitive sense, okay? Here on the right, you see there are two best friends. They're going on a run. They both are running at 4 meters per second. They both are going side by side, all right? In the same direction at 4 meters per second, okay? So if we are this person, let's say, I would ask you a question. From this person's frame of reference, what is the velocity of his friend? All right. So if you think about it, if you're running at 4 meters per second and your friend is right next to you, if you turn to his right and look at him, you would see that he would look stationary to you because both of you are running at 4 meters per second. So if you look at him, he would appear as if he's stationary. So from your frame of reference, your friend, or you can say that my friend appears to be traveling at a velocity of 0 because we both are traveling at the same velocity. So I feel like he's traveling, or not feel, I know that he's traveling at the velocity of 0 from my frame of reference, all right? Let's change the scenario now. Let's say that same friend, let's call him friend A, and the other friend is friend B. So friend A is traveling towards the right at 4 meters per second. Friend B is traveling towards the left at 3 meters per second. Now, from the frame of reference of friend A, what is the velocity of friend B? Okay. Now, when I say from friend A's frame of reference, in the previous example where they were going in the same direction. So what did you do? You just subtract the velocities. Both of them were moving at 4 meters per second, 4 meters per second, and you got a 0 because they were moving at the same speed. If you're coming at each other from one person's frame of reference, you're going to be adding both these velocities. So if I'm moving towards the left at 3 meters per second, and the other person is coming at 4 meters per second, it will be 7 meters per second from my frame of reference. So from the frame of reference of A, the velocity of B would be 7 meters per second. And that would be the same for B's frame of reference. So from B's frame of reference, the velocity of A would be 7 again, but these would be in opposite direction. All right, with me? So let's go to a final example. Okay, this is a 3 scenario case, all right? So here are 3 scenarios, okay? Let's say this is the ground. So let me just make the ground here. This is the ground, the car is on the ground, the car is on the ground, all right? The first scenario, okay? You are on the ground, okay? You are on the ground, you're stationary. Let's answer a few questions now, okay? Let's also say that this train is moving at a velocity of 100 meters per second, all right? Pretty fast train. Okay, 100 meters per second. So let's answer a few questions. From my frame of reference, and I'm on the ground, and I'm stationary, all right? What is the speed of the ground from my frame of reference? And you would be right if you said 0, because you're stationary, the ground is also stationary. So from our frame of reference, the velocity of the ground is 0, okay? From our frame of reference, what is the velocity of the train? It should be 100 meters per second towards the right. So the train is moving towards the right at 100 meters per second. So from our frame of reference, the velocity of the train is towards the right at 100 meters per second. Fair enough? Okay, let's go to the second case now. Let's say you're in the train, all right? You're over here. So your frame of reference is from the train. You're in the train. You're again moving towards the right at 100 meters per second, okay? Towards the right. Let's say this car is moving towards the left at 20 meters per second, okay? Now let's again answer a few questions. Let's say from my frame of reference, if I'm sitting in the train, what is the velocity of the ground? Okay. If I'm in the train, it would appear as if the train for me is stationary. So it would appear that the ground is moving towards the left. At what velocity? At the velocity the train is moving. So that will be towards the left 100 meters per second. Because I'm in the train, for me, the train is stationary. So I see when I look out the window that the ground is moving backwards. At what speed? At 100 meters per second. Okay. So if I'm, second question. If I'm in the train and I look at this car is moving towards the left at 20 meters per second. From the frame of the ground, if I'm at the train, what do you think I would feel the velocity of the car is if I'm looking at the car from the train? It would be 100 meters per second plus 20 meters per second. You remember this example that we did where we added the velocities because they were in opposite directions. We do the same thing here. So the velocity of the car from the train, if you're sitting in the train, it would be 120 meters per second, all right? And what would be the velocity of the train for you? The velocity of the train would be 0 because you're in the train, all right? Let's do the final case. Let's say you're in the car again, okay? You are sitting in the car and the train is again moving at 100. Let me just write that down at 100. The car is moving this direction, 20 meters per second, okay? Let's answer the questions again. What is, from your frame of reference in the car, what is the velocity of the train? And you would say the velocity of the train is towards the right, 120 meters per second. Why? Because when you're in the car, from your frame of reference, the car is stationary. But from the ground, the car is moving towards the left at 20 meters per second. So it'll be 120 meters per second for the speed of the train, velocity of the train, all right? What would be the velocity of the ground? Now, if I'm in the car, I look outside of the window, it would appear the ground is moving that way, all right? The ground is moving that way. What velocity? 20 meters per second, all right? So that is that. And the car would obviously be stationary if you're inside the car. That is your frame of reference. All right, so what we discussed here was the frame of reference. We got an intuitive sense of what it meant to have different frames of references. So thank you so much for watching this video. If you have any doubts or any comments, please leave them in the comment section below. And thank you so much for watching. Bye-bye.